Hey everyone, my name is Melanie, Math Content Specialist here at Zinkers. Let's take a look at another digital SAT question and how we can use Desmos to help us solve it. This question says, the functions f and g are defined by the given equations where x is greater than or equal to 0. Which of the following equations displays as a constant or coefficient the maximum value of the function it defines, again, where x is greater than or equal to 0? And then here we're given the functions defined for f and for g. So there is certainly a way to answer this question without doing Desmos, just by kind of using some logic and using rules of exponential functions and rules of exponents. But for today's video, I just want to show you how to do this question using just kind of some basic definitions, and then again, letting Desmos really give us the visual and guide us to the answer to this question. So before I jump to Desmos, I just want to kind of clarify what this question is actually asking us. A lot of words here, a couple of functions to deal with. So what we're really doing is matching two numbers. We are matching a constant or coefficient with a maximum value. So the constant or coefficient is going to be this 33, this 0.4, again is 33 right here, 0.16, 0.4. These are the coefficients or constants as they are displayed in each one of these functions. We want to match those numbers, one or both of those numbers, with the maximum value of the function. And that's where Desmos comes in. Desmos will give us a visual of what that maximum value looks like. And we're working within some constraints, which I'll jump to in Desmos in a second, but x is going to be greater than or equal to 0. So that'll become important just when I, again, use Desmos as a visual. So let's jump over here. I'm going to plug in these functions exactly how I see them, starting with f. And then just a quick little tip here, use some parentheses for your exponent, just so Desmos cooperates a little bit. It'll want to jump back down. So just use some parentheses there. And then in order to input our parameters here, our x is greater than or equal to 0, we'll use these little curly brackets. And then make sure we're doing equals to 0, closing my curly brackets. And here is a picture of the function of f. And you can see it cuts off the function when x is less than 0. We just have this picture right here. I'm going to do the same thing for g. So g is equal to 33, 0.16, 0.14. Again, using some parentheses right here, x minus 2. And then inputting our parameters, x is greater than or equal to 0. And again, that just kind of cuts off my picture. I'm getting an idea of what this function looks like. You can see the green line just cuts off right there. So now what I'm looking for, again, I'm matching my numbers. I want to see anywhere, which is 33, 0.14, 0.16, match with the maximum value of this function. So here we can see the maximum value of f is 2.12 or 2.11. That doesn't really show up anywhere in function f, right? Nothing I can see here gives me that 2.1 number. So we know f is not going to be our answer. And we can do some process of elimination just when I crossing out some answer choices there. And then let's take a look at function g. Function g has a maximum value of 33. And again, that's going to match up with the numbers we're looking for. Here's that 33 constant coefficient that we're looking for. And so that is going to be our answer. We know that function g, not function f, displays a constant or a coefficient that matches its maximum value. So I know that b is going to be my answer. Is there another question that you want to see? Make sure to leave a comment down below, and don't forget to like and follow our channel for more digital SAT content.